Assalamu alaikum, grade 9s. Today we're going to be doing section 4.3 and 4.4 because they're connected. 4.3 is all about something called similar triangles. So we are going to start with that. Working example number 1 says to identify similar triangles. So before we do that, we have to actually define what they are. So similar is a different definition in math. So similar figures, similar figures are two or more figures that have the same shape but different size. Okay? So it's an enlargement or a reduction of each other, basically. All the corresponding angles are equal and all the corresponding sides are proportional. What does it mean to be proportional? Proportional but not equal. I guess that's why there's two lines here. So not equal, but they are proportional. What does proportional mean? Proportional means that the ratio of the corresponding sides is equal. Okay? Ratio means, remember, that you're dividing them by each other, which we're going to talk about in a second. Before we get into, what is the definition of similar and similar figures, which we wrote already, we have to talk about what is a corresponding side and a corresponding angle. So corresponding angles and corresponding sides are basically angles and sides that are in matching positions. Okay? So for example, if you look at these two triangles, B would correspond to E because they're both the right angle triangle. A corresponds to D, they're both the top of the triangle, and C corresponds to F. So the corresponding angles here, this symbol represents the word angle. Okay? So angle A and angle D are corresponding. Angle B and angle E are corresponding, and angle C and angle F are corresponding. So if those are the corresponding angles, what are the corresponding sides? So corresponding sides are basically the ones that are in the same position. So side AB corresponds to side DE. Side BC corresponds to side EF. And then side AC corresponds to side DF. So they're in the same positions as each other. Okay? This is just repeated. We already wrote the definition up here. Okay? So in order for two objects to be similar, they have to have the same shape but different sizes. The corresponding angles have to be equal to each other, and the corresponding sides have to be proportional, but they're not equal. Okay, what does that mean? Let's look at these two triangles right here to see if they are similar to each other. Okay, so remember the two conditions for them to be similar. So they have to have equal corresponding angles and proportional corresponding sides. Sorry, excuse my printing. Okay, so equal corresponding angles, proportional corresponding sides. So let's check the angles first. So are the corresponding angles equal? Well, angle D, which is 45, would correspond to angle A here, which is also 45. So they are equal to each other. Angle E is 60, which corresponds to B, which is also 60. That checks out. And angle F is 75 and angle C is 75, and that means they're equal and they're corresponding. So all the corresponding angles are equal. So we are good. If 2 out of 3 are equal and the third one is not, then it is not a similar triangle. All 3 of them have to be equal. Okay, let's check the proportionality of the sides. So side DE corresponds to side AB, right? So the definition says in order for them to be proportional, the ratio of the corresponding sides has to be equal. So we have to find the ratio of the corresponding sides. So the ratio of DE to AB, which are two corresponding sides, is 3 to over 1.5, right? Which is 2, if you divide them. That's the first corresponding side ratio. Let's check the next one. EF corresponds to BC. So EF corresponds to BC. So 2.2 over 1.1, that's equal to 2 as well. So far the ratio is the same, but let's check the third one. DF corresponds to AC. DF is 2.6, AC is 1.3. When you divide them, you'll get 2. So in each of these cases, the ratio is 2. So that means that all the sides are actually proportional and it was enlarged or reduced by a factor of 2. Okay, perfect. Let's look at an example here and let's try to figure out, are these two triangles similar? So is triangle EFG, so it's labeled based on the 3 points. So is triangle EFG similar to triangle ABC? So let's figure this out. So in order for them to be similar, 2 conditions, right? Corresponding angles have to be equal, corresponding sides have to be proportional, right? These are our 2 conditions. Let's see if they check out. Let's check the angles first. Angle A corresponds to angle E, and they are both 90 degrees, which means that they are equal. Angle B corresponds to angle F, and they're both 37 degrees, so they're equal. And we don't know what angle C and angle G is, but we know that in a triangle, this is something we should know, all angles in a triangle add up to 180 degrees, okay? So to get angle C is equal to 180 degrees minus 90 degrees minus 37 degrees. And would that be the same thing for angle G? It would, which means that they are equal to each other, whatever the angle is. So our corresponding angles are equal. That checks out. Now let's check if our corresponding sides are proportional. So to find if they're proportional, you have to check the ratio. It doesn't matter when you're checking the ratio if you do the big triangle over the small triangle or the small triangle over the big triangle, but you have to be consistent with all 3 of your ratios. So if you do big triangle over small triangle, then you have to do it for all 3 to check. You can't just flip it halfway. So let's check. Side AB corresponds to side FE or EF. And side AB is 12, side EF is 4. When you divide them, you get 3. So this is our first ratio. So we're doing big triangle over small triangle. Let's do our next one. Side AC corresponds to side EG. AC is 9, EG is 3. 9 divided by 3 is 3. Perfect. That checks out. And our last one is side BC corresponds to side FG. BC is 15, FG is 5, 15 divided by 5 is 3. So is our ratio the same for all 3? Yes, it is. So that means all of our corresponding sides are proportional. So if our corresponding angles are equal and our corresponding sides are proportional, then that means that triangle EFG is similar to triangle ABC. It is just simply a reduction of this triangle. Okay? Perfect. So pause the video. I want you guys to pause the video and I want you to try the show you know. I want you to figure out A and B, checking if they're similar to each other by checking the corresponding sides and the corresponding angles, and then come back and unpause the video to check your answer. Okay guys, here are the answers to the show you know. Part A, they were similar. Part B, they were not similar. You can pause the video and check the work if you did not get those answers. So moving on to working example number 2, it says we're going to be using similar triangles to determine a missing side length. And the first question says, Wajia is drawing triangles for a math puzzle. Use your knowledge of similar triangles to determine A, B, whatever they're asking for in part A and B, part B. So here are 2 triangles. And we have to check first if the triangles are similar. Okay, so let's check their angles. We know that angle angle M corresponds to angle V, and they are both 85 degrees, so that works. We know that since a triangle, all the angles add up to 180. To find our missing angles, we can do 180 minus the two angles that we have. So when we do 180 minus 50 minus 85, we would get 45 for this missing angle. And then if we do the same thing here, 180 minus 85 minus 45 gives us 50 degrees for this angle. So that means that angle K, which corresponds to angle T, they're both equal to 45. And angle L, which corresponds to angle U, they're both equal to 50. And so they are equal. So the angles are all equal, which means that the triangles are similar. What you can do is you can actually find the proportions of the side length to double check. For example, 24 divided by 8 is 3. 21 divided by 7 is 3. So we know that the triangles are similar to each other. Okay? Now, it's asking us what is the missing side length. Okay? So the missing side length is on the big triangle, this one right here, X. So what we have to do, there's two methods. Method one is to use a scale factor. Method two is to use a proportion. Okay, so first, if we want to use a scale factor, we have to figure out what the scale factor is. So we want to find out X, right? And we know that side TU corresponds to side LK, which is what we're trying to find. And TU is 10.5. So we want to say 10.5 times something will give us LK, which is our missing side length. We need to figure out what that something is. So if we look here, we know that side UV corresponds to side LM. So to get from UV is 8, LM is 24. To get from UV to LM, we multiply by 3. So the scale factor is 3. So to get our missing side, all we have to do is take 10.5 times 3, and that will give us 31.5, which is our missing side length of X. To double check, you can do 31.5 over 10.5, and that will give you the same ratio as all the other side lengths, which is 3. Okay, this is to check. So the first way is to find the scale factor and use it. Method two is to use the proportion, is to set up a proportion. So we know that the triangles are similar, which means that all the corresponding sides have to be proportional to each other. So since the triangles are similar, we can set up a proportion. We know that, let's say, side KM is proportional to side TV, right? And when we want to find the ratio of those, we know that that has to be equal to all the other ratio of corresponding sides, which would be KL over TU. So side KM over TV has to be the same ratio as side KL over TU. They have to be equal in order for them to be similar triangles, which we already determined that they were. So let's plug in what we know. We know that side KM is 21 and side TV is 7. KL is unknown, so I'm going to put it as X, and side TU is 10.5. So now it's just a classic case of cross multiply and divide, or you can try to figure out what the proportion is again. So there's two ways you can do this. The first way is you can say, to get from 7 to 10.5, what do I have to do? Well, if you divided 10.5 by 7, you get 1.5. So 7 times 1.5 gives you 10.5. What you do to the bottom, you would have to do to the top. 21 times 1.5 is 31.5. The other way you can do it, which is what we're more comfortable with, I think, is to solve by cross multiplying. So we have 21 over 7 equals x over 10.5. To solve for x, we can cross multiply, where we get 21 times 10.5 equals to 7x. Now 21 times 10.5 is equal to 220.5, which is equal to 7x. Then if we want to get x by itself, you divide both sides by 7. And then you get that x is equal to 31.5. So there's a bunch of different ways that you guys can do this, you guys. And honestly, like, it doesn't matter which way you do it on a test. Knowing a scale factor is important, but it doesn't matter which way that you solve it, okay? As long as you know how to solve it. 3 different ways that you guys learned here, and you can do it any way that you would like. So this is a show you know. I want you guys to pause the video. It says solve using any method of your choice, either using the scale factor or the proportion or the cross multiplying. Okay, so pick a method that you want and answer these 2 questions and come back and check your answer. All right, guys, so for the first one, you should have gotten that x is equal to 2.5. For the second one, I'm going to do it with you because it's a little bit trickier. So it says here, and the first thing that I have to tell you is that there was a number missing, so make sure you write this down. EF is equal to 5.9. So it says here triangle ABC is similar to triangle EFC. So ABC, triangle, this big triangle here, is similar to triangle EFC. So, and then it says determine the missing side length. So it's telling you that they're similar, so you can use proportions to solve it. The biggest mistake here is that people will use the wrong numbers when they're drawing out their proportions. So here when we have triangle ABC, and then you have triangle EFC, okay, we wrote down that this is 5.9, this is 8.7, and this is 10.5. So we have all the dimensions of EFC. Again, this wasn't written. Make sure you write it down. It was just missing. Now for ABC, we have X here. And then from B to C, a mistake people make is that they'll say it's just 7.2. They'll ignore the 8.7. That's not true. B to C is from here to here. So it's 7.2 plus 8.7, which is 15.9. Same thing with the top here. People always say that side AC is 8.7, which just stops here. And that's not true. It's a combination of 8.7 and 10.5. So when you add them together, you should get 19.2. So now the hardest part is determining that these are the numbers you're working with. And now you pick 2 sides to set up your ratio. So I'm going to say triangle AC corresponds to, side AC, corresponds to side EC. And then EF corresponds to AB, which is our missing side that we want. And I'm going to plug in the numbers that I have. AC is 19.2. EC is 10.5. And when I divide those 2 together, I'm going to just use a different method this time. I'm going to use the scale factor method. The scale factor is 1.83. So that means that AB is equal to 1.83 times EF. Okay, it's the scale factor because this times 1.3 gives us that. So this times 1.3 should give us X, which is X. So then I would do 1.83 times 5.9. And I got X is equal to 10.8 if I round it. And that is our answer for that question. All right, that's it for 4.3. This is your textbook practice. You will need some practice with this. Make sure you guys complete it, okay? I believe that the 4.4 homework is attached here, which is the page 157. So make sure you guys do this. I'm going to just right away roll into 4.4 because it's the same thing as 4.3, except instead of dealing with triangles, we're dealing with similar polygons. And a polygon is just any other shape. other than a triangle. Okay, so similar polygons are the same thing as similar triangles. They have proportional corresponding sides and equal corresponding angles. Okay, so it's really quick. It's just 2 pages. So working example number 1 is to identify similar polygons. So it says the two quadrilaterals. Quadrilateral means it's 4-sided. They look similar, but are they actually a true enlargement of each other? So if we take a look here, it says, is math an enlargement of math? So M prime, whenever you see this like prime thing right here, this little dash, that means it's an image. Okay, so it's either been enlarged, it's an enlargement, or it's been reduced. Okay, so it's not the original. If it doesn't have the tick, that means it is the original. That's how you know. Okay, so it's saying, is this one an enlargement of this one? Well, let's check. Are the corresponding angles equal? M corresponds to M prime? Yes. H corresponds to H prime? Yes. 100 corresponds to A prime? Yes. And 80 corresponds to 80, which is T and T prime? Yes. So all the corresponding angles are equal. Now let's check the sides. So again, it doesn't matter which one you start with. It just matters that you, like if you do the image over the original or the original over the image. So I'm going to do this time the image over the original. So side M prime A prime over MA. These are corresponding sides. So 1.54 over 1.1. When I divide them together, I get 1.4. So let's check the other ratios. M prime H prime is proportional to MH. So 4.2 over 3, which is also equal to 1.4. If we keep going, H prime T prime is proportional to HT. So 2.1 over 1.5 is also equal to 1.4. And then our last one, A prime T prime is proportional to AT. So 4.9 over 3.5. This is also equal to 1.4. So I checked them all with my calculator. So all the corresponding sides are proportional and all the corresponding angles are equal. So yes, because of what I just said. Okay, the corresponding sides are proportional, the corresponding the corresponding sides are proportional, the corresponding angles are equal. So we're going to skip this one because it says you need a ruler and a protractor. We're not going to do that. You're not going to have to do that on your test. So let's move to working example number 2, which is using similar polygons to determine a missing side length, just like we did with the triangles. So it says Jason has 2 Nunavut flags. Rectangle JKLM is similar to rectangle PQRS. So it's already telling you that they're similar. You don't need to do the work. Then it says find the missing side length of JKLM. So the missing side length meaning the one that's labeled X here. So what you have to do to find the missing side length is find 2 sides that you do have in order to find the proportion or the factor, okay, or the scale factor. So I'm going to say that side KL is proportional to side QR. And KL is 32, QR is 5. If I divide them, I get 6.4 as the ratio. Then that means that RS, you have to keep the same triangle. So LM, which is our X, is what we need, over RS, which is X over 9, has to also equal to 6.4. Now, if you look at this like an equation that you need to solve, there you can use the one-step equation method that we've been doing. X over 9 equals 6.5. So to solve for x, multiply both sides by 9. Sorry, guys, it was 6.4, not 6.5. And then 6.4 times 9 is 57.6. So x is equal to 57.6. That's our missing side. You can always double check by doing 57.6 over 9, which is equal to 6.4, which is the same ratio as the other side. Okay? All right, guys, pause the video. Try this last show you know, and then come back and check your answer. All right, grade 9s, the answer for this would be x is equal to 9, which is our missing side. There was only one real corresponding side that you could use because they were both given as our proportion to find our scale factor and then solve. All right, pause and check if you didn't get this answer. Your homework for 4.4 is included here with the 4.3 homework. So these two are what you need to get done to practice section 4.3 and 4.4. And that wraps up chapter 4, you guys. And we're going to move on next week, inshallah, to chapter 10, which is our last chapter of math. All right, assalamu alaikum, everyone.